I want to talk to you about what we're studying, how all this fits in. So this is our standard that we've been looking at. What we want to do is identify the effect on graphs of replacing f of x with various transformations, f of x plus k, x plus k, k times f of x, and f of k times x. For various specific values of k, both positive and negative. That's a lot of words. So if we just take a look at a function that you're very familiar with, we have log base 10 of x, okay? And so we know that this function has lots of really interesting points. We know that if we went out to 10, what's the log of 10? Functions are a major part of Common Core. The reason why functions are important is that they are the building blocks that we can use in other mathematics courses, in our science courses, and in careers. Because the same manipulation that you do with one type of function applies to other functions too. So let's suppose I wanted a log function. Graph, similar shape. But instead of going through the point 10, 1, I wanted it to be 10 and 3. So this is the original function, y is log base 10 of x. And now I want it to go through this point 10, 3. Any idea what I could do with this function based on what we've been doing this week?
Shift the graph up 2.
And how do we do that? What would this new function look like?
Y equals log base 10 of x plus 2.
Bailey, when you said that, there are two things you could have meant. You could have meant what I wrote the first time or what I wrote the second time. So both of these could be pronounced log of x plus 2. Tell me, blue or red?
Blue.
Blue, excellent, okay? So let's take a look at what the other one does, okay? Well, log base 10 of x plus 2. For the previous 2 days, we looked at two types of transformations. We call them shifts. A vertical shifts where the function is raised or lowered, and horizontal shifts where the function is shifted left and right, or the graph is shifted left and right. What today's lesson was about was stretching and shrinking functions by applying a transformation. The idea was for the kids to explore these transformations via their calculator.
When you add 2 to x, so it would basically, instead of it being 10, 1, it would be like 12, 1.
Well, it could be a square root, but what's going to happen to this graph? Okay, Bailey said his graph is going to move up 2. This graph is going to go what? What's going to happen?
To the right.
Say it louder, please.
To the right.
It's to the right, okay? Okay, so guys, can you type this in your calculator? And what Imani has suggested is that one function is shifted to the right. Right? Do you need help with that, anybody?
Is it like this?
Okay, yep, okay.
And then for the
Okay, and then use the basic function, just log of x, okay? And see what the relationship is. Shrika, would you be able to share your window and tell us what you have in your window?
In my window for x min is -10, and x max is 10. My, I guess that's his scale, x
yeah.
scale.
Yeah.
Is that what that is? Is 1. The y min is -1. The y max is 4.
Okay.
The y scale is 1.
Okay. And so it may help if most of you do that. And what we're comparing are two functions. The original function is log base 10 of x, like this. And the new function replaces the x with x plus 2. And the question is, based on what you did yesterday, what is the change?
It looks like the graph shifted to the left 2 spaces.
Excellent. You add 2 to something, you think about shifting to the right. But you may remember from what we were discussing yesterday that there was a negative sign in a lot of the problems you're doing. And so here, basically, this plus 2 is the effect of 2 negative signs. And I believe that Bailey is correct that the new graph is going to be shifted 2 spaces to the left. And I suspect that the other one is in some sense parallel to it, going through -1, 0. Is this what you're seeing on your calculators? Yes. Great, okay? So guys, this is the whole idea of translation, okay? What happens if we multiply the function by a number? Okay? And here, later on, what if we take f of kx, and what happens there? So we're looking at various transformations. This works for every function. The reason why functions are important is they have common properties. I don't have to do this with logs, exponents, trig functions, absolute value functions, etc. Once you've learned the effect of these transformations, they apply to any function whatsoever. Yeah, yeah. So you can see that your new function is less high than the old function. The old function went off the calculator.
Okay, because I don't know why my other graphs aren't showing up.
Probably because they didn't recognize the way you typed it in.
Just keep sharing your information.
Oh, okay, so we have to plot where y1.
We had to
Oh, so this is just setting the window, right, B?
yeah.
Okay.
One of the standards of mathematical practice deals with modeling. And these functions, logarithms, exponential functions, polynomials, are our building blocks.
I want to take a look. We had this, funny 4th degree polynomial that you called y1. And would anybody like to volunteer, based on this graph, what was y2? What does that look like?
It's half of the original equation, which is considered to be y1.
Exactly. Okay? So when you multiply by 1/2, it's going to be half as high and half as low. How about when we multiply it by 4? What's going to happen?
It's gonna be 4 times as big as the original equation.
Everybody okay with that? So I just want to give you a bigger picture of how this fits in with real situations. They are basic functions that we're studying. You may have sensed that there are all these different log functions because they're different bases. For me as a mathematician, I see log functions as a family of functions. I can manipulate them by these sorts of transformations. Exponential functions in the same way. We can manipulate them. These become building blocks. So what architects do is they take these building blocks and they adjust them to various conditions. So if they want the building to be 30 feet high, they multiply by 30. If they want it to be 6 inches high, they might divide it by 6 or something like that. They're basic building blocks that people use. And this sort of structure is what we look for in chemistry and physics.
The advent of Common Core creates a crisis for teachers because they're going to have to start doing things differently and teaching things that they've never taught before, often with material that they don't have in their hands. But at the same time, it may be really exciting because here there's a cohesive way the material has been put together.
For Tuesday, I'd like you to finish both of these 2 recent lessons. Would that be okay? Yes. You've had a great start on this. Any questions before I dismiss you? Okay. Thank you very much. Have a great weekend. You too. Okay.